So we are going to talk about some best practices for industrial wireless deployments. Now, in this, I'm not going to get into nuts and bolts of protocols. I'm not going to talk about, you got to hold your jaw this way and keep your arm out to get that. We're not going to talk about super intricate things. What we're really going to do is more of a higher level, more of an interactive level on things that you need to pay attention to. Knowing this stuff will really make you help you be the go-to guy for your industrial client, because they're coming to you because you're the expert. Well, you need to have familiarity, because the industrial environment is a lot different than anything else. So there's a lot of things that you need to be aware of, and you really need to pack your mental tool bag and be prepared for all this stuff. So my name is Scott McNeil. I work for a company by the name of Global Process Automation, GPA. We are industrial automators. So about half of our staff are actual industrial engineers, process control engineers that make the actual processes happen. We've got a stable of developers and machine intelligence people. Then there's our OT infrastructure group, which is what I'm a member of. And I'm also the company's only wireless guy. So hopefully I won't get hit by a bus. I'm on LinkedIn. You can hook up with me there. I probably read more tweets than I post, but I like hanging out on Twitter. When I get the time, I do like to write about some of my experiences on my blog, the Industrial Wi-Fi Shop. And if you want to know more about GPA as a whole, you can check out our website there at global-business.net. So best practices for the wireless engineer, and this is just kind of a general thing, and it's important stuff that you need to know, you need to pay attention to, and you need to be able to express to your clients. So you need to know more than just Wi-Fi. And a couple weeks ago, you guys had Lee Badman on here, and he did an entire webinar about this. And I thought that webinar was awesome, because it is so important as wireless engineers that we know more than just 802.11. Granted, 802.11 does make up the vast majority of what we do, but there's still so much more out there. When you get into the industrial world, you have all of your standard IoT protocols, but two of these really big ones are right there in the center. It's Wireless HART and ISA 100 wireless. Now, both of these guys do happen to be 802.15.4 based. So you should be familiar with, it's layer 1, layer 2 MAC address stuff. But once you hit layer 3, everything above that is going to be handled completely differently than how 802.11 interacts, because all the rest of that is not defined by the standards. So there's a ton of proprietary things beyond that. Am I saying you have to go in and know all the specific ins and outs? No, but you need to understand, the basics, number one, of what Wireless HART uses. As we talked about in the trivia question, what modulation is it using? So you need to be able to recognize that modulation. Same with ISA 100. You need to understand that these as protocols are capable of 128 AES encryption, because that's part of the 802.15.4 standard. But there's a ton of stuff on top of that on how it handles the data that's going to be completely foreign as compared to 802.11 in general. So there's really a lot going on with that. And the other thing is too, when you're dealing with all these technologies that are not Wi-Fi, you lose several very important troubleshooting tools. So you're not going to pick these up on a Wi-Fi scanner on your phone, because they're not 802.11 structured communication. So your Wi-Fi scanners are not going to be able to really give you any information about that. On that same token, passive survey stuff, be it, I don't care what you're using, be it air magnet, be it Ekahau, be it Tamograph, whatever you're doing that survey with, it's not going to show up, because this is a completely different communication structure. So you can't even heat map it out. So you have to be aware of your other tools that you can use to figure out what's going on, which then leads us into this, is how much you have to realize that spectrum analysis is incredibly important to our job as wireless engineers, but even more so on the industrial front. Because you lose all of those other tools in order to be able to troubleshoot this stuff, you at least have spectrum analysis to fall back on and take a look at the raw RF of what's going on. And this can save your bacon in troubleshooting deployments when you're looking at these different things. Because yeah, you know that they're complaining that wireless is terrible in this one area, but you can't figure out why, because you can't get a packet capture. You know, it's not structured communication. You can't sit there and pull out your phone and try to find out, you know, whether or not you're eating up all these channels, because again, it's not that structured communication that your device is tuned to. So you're not seeing the results of any of that. And just a couple weeks ago, I ran into this very problem at a parts warehouse at a heavy industry facility that I was at. Jim, this is the one I shared on Twitter, and you were the one who got it right. This is what frequency hopping looks like on 2.4. But because it wasn't 802.11, it wasn't showing up as other traffic or as co-channel interference or anything like that. My G2 picked up some non-Wi-Fi based interference, and that clued me in that I needed to bring in my spec in and start taking a look. And sure enough, I was able to see very clearly that all of it was being eaten up, and it looked like frequency hopping to me too. So that keyed me in on a few things to go look for. As it turned out, this was a wireless camera system that was running throughout the warehouse, and they had 12 different wireless cameras that were all running on frequency hopping spread spectrum, and everything was maxed out at 16 dBi, and it was eating up all of the airtime in 2.4. As you can see below, it was well over 50% across the usable spectrum, but 802.11 devices just saw it as very heavy background noise. Now, again, SpecN is the tool that allowed me to find the problem. And all of these examples just really exemplify the importance of spectrum analysis. Now, I was running some tests, and this is 900 megahertz. I've got this other additional tool that I picked up that I use now, and it is this little guy right here. This is a little small handheld spectrum or analyzer. This particular one does sub-gigahertz frequencies, but it's also a signal generator. So I was able to generate a pretty high-powered signal in the ISM bands for 900 megahertz, and because I just wanted to see what it was looking like, but I could also use it for penetration testing to know how far 900 megahertz is going to be able to penetrate through, say, walls or this band of piping or whatever. But now that I know what that signature looks like, also, if I see that signature out in the wild, then I'll know that someone else is using some kind of signal generation and or jamming technique, because this is one of the several signatures that will key you in on that. Now, this one was really interesting. It was, again, I was at a big manufacturing facility, and they were having problems in a very specific area. I had several long conversations with what do I say? Jim Palmer. Jim Palmer, thank you. And Jim was able, by looking at the waterfall graph and its signature, he was able to figure out, you know, and tell me what that was. And I already knew what it was, but he was the only person who figured it out because of his long history in spectrum analysis, and how the signature, especially when you're looking down here and you get these sweeps that kind of come out, this is microwave related, and that was the magnetron sweeping the signal out. So, you know, again, these aren't going to show up on your standard scanners because it's RF noise as far as our standard 802.11 devices are concerned. And then it's also good to know when your environment is just completely screwed and there's nothing you can do except move on to another frequency. When it's so eat up that there's no chance of mitigation, at least this is going to let you know that you need to throw in the towel on 2.4 and migrate to 5 gig or 6E if that's available at the site, you know. So understanding the importance of spectrum analysis, I really can't put enough emphasis on that. And then having the tools to do it properly.
What is that last graph there? Did you identify what the interference source
Yes,
was?
that was an infrared curing machine at a roofing plant.
Okay.
So it cured the adhesive to the backside of the roofing material.
So
And
what?
being that that was a a $500,000 machine, they weren't changing it.
Yeah.
So, but at least now they know, and we were able to migrate everything over to 5 gig. Another thing is you need to really get familiar with industrial wireless devices. Some of these, like if you look to the bottom right there, the Antera access point, and then that Siemens Scalance AP, they're what you're used to dealing with. That they have all the various flavors of 802.11. They can do all of your fast roaming. They can do wide channels, narrow channels, whatever. It's all your standard AP stuff that you're used to using in the standard world. The only difference with those is they're built heavier. It's steel casing. They're sealed for the environment. They can handle higher heat. But when you look at these other guys, they're completely different. Like this one, this is a little industrial radio by Phoenix Contact. It is designed to mount on a DIN rail. It is not designed to be mounted up on its own. You run your pigtails off to external antennas. And, like a lot of industrial radios, this guy is 10100. He is not gigabit. Because the throughput values that are needed in general are a lot less. You don't need gigabit throughput on your data side. This ProSoft can do a lot of what you're familiar with, but even then, it's an 802.11n. This is a very prevalent one you'll see out in the field. But something else you have to take in consideration is how it's powered. Some of these are dual as far as it can be PoE powered, but a lot of the times it's a DC power supply that's 12 to 24 volts. So you have to hardline this in along with other DIN rail mounted equipment. So usually when you're mounting these in the cabinet, you're not using these little rubber duck antennas, you're using external antennas. A lot of these guys are designed specifically to fit in these DIN rail cabinets. They're just a completely different animal. Then you have something like this, which this is a wireless IO radio, input output, specifically designed for industrial communications. So you don't log into this to configure it. There is no web interface. It's all configured on the dial on the front. It uses a proprietary protocol, although it is based on frequency hopping. And this just communicates to other nodes similar to it, and then talks directly to your PLC or DCS. And so this guy is a completely different animal, and he's running at 900 megahertz. So there's a lot of different types of hardware that you need to become familiar with. I'm not saying you have to know all 1,000 brands out there, but it's very helpful to be familiar with the radio types, how they install, and what powers them. And then, when it comes time, you can research the more specifics like radiation patterns and things like that when you have a specific project that you're tailoring the install to. But all of this hardware, it's really good to have that basic working knowledge because of the differences compared to your standard Aruba or Cisco ceiling mount office AP. Now, kind of some best practices for the project overall is, and I found this incredibly helpful, is you need to understand what they're making and how they're making it. I'm not saying you need to go in and study the chemical processes, and I'm not saying you need to know what alloys they're using. I'm not saying all that. But if they're making paper, understand the base processes that are going on, and realize that there's a wood processing facility, there's a chemical processing facility, then there's the actual slurry processing. They normally have a power plant on site. Understanding all of these extra parts will help you better understand the role that wireless is going to play and what it's there for. And just in general, the more you know, the easier it is for you to make informed decisions on how to best guide the project, because they're looking to you. You're that wireless expert that they are relying on to make this project work. And so you have to understand just as much about them as they need to understand on how to make it work, which falls right into really getting to know the physical environment. And there is no substitute to going on site. So if you're going to get into industrial wireless in general, understand that you're going to have to go on site. There's not really any sort of armchair quarterbacking you can do for this. You need to be on site because you need to understand really what's going on. So an example is this is where I was several weeks ago. This is a smelting facility, you know, and when you're just looking here, you can see that, you know, part of the stock that they're rotating through, these are blocks of metal. Some are alloys, some are fairly pure. Over in the corner, you have a huge rubble pile of pieces that didn't make the cut that'll be melted down later and recast. What you're not seeing in this picture are the big, you know, 1,000-pound blocks that they have rows of that are rotating in and out, that they can only pick up one at a time with a forklift. Then you see up in the ceiling, you've got all of this vapor hanging out. You've got these gaps in the walls. The walls themselves are corrugated steel. The ceiling is corrugated steel. You have all of this metal as far as the stock is concerned, reinforced concrete flooring, fork trucks running around. You need to be able to really get a grasp of everything that's going on so that when it comes time to do the actual design, you know, you've got to think about hardware types. What's going to survive in this environment? It's exposed to the elements. It's exposed to a lot of extra moisture that normal APs would not be exposed to, let alone dust, possible metallic dust, depending. You know, you've got to be able to take all these factors into consideration before you go back and start looking at your industrial APs to see what you would put up in here. And because you know what the materials are, you know it's going to be a highly reflective environment. You're going to have to make sure that you plan for lower power levels, smaller cell size. You want to reduce that multipath as much as you can. Because in this particular project, yeah, it's for inventory control, but the driving force behind this is for the body sensors that the guys around the smelter will be wearing to monitor them while they're working in these conditions. So these are safety, and this is a much higher priority than whether or not you can watch, you know, cat videos on YouTube. Whoa. And then you can take it in the complete opposite direction and be completely outdoors and you're on other mobile or moving heavy machinery. This gigantic device, you can see the golf cart down there kind of for scale. This is a wood chip stacker reclaimer. The top part spins and rotates. The bottom part spins, rotates. It has a lot of moving parts. So now you have full on weather exposure, sun, heat, rain, wind, cold. On top of that, you're going to have to take into consideration the vibration of this equipment. So when you go back and you're trying to spec out hardware for this, you're going to have to really do your research and make sure you're finding the right mounts. You're using the right radios, what's going to be able to handle vibration of that caliber that you may not have seen if the only thing you saw were pictures, as opposed to actually going on site and climbing on this thing. So there is no substitute for going on site when it comes to industrial wireless deployments. So best practices for installation. These are really these are some important points to remember. And really these kind of go across the board for any kind of deployment, but especially for this environment. You want to make sure you're using the correct wireless device for the application and environment. And this just goes back to exactly what we were just talking about, looking at the examples that I put up. You're not going to go and put in an Aruba 315 you know, office AP and call it a day, because that sucker is going to last 6 months and then it's going to be toast. But even then, you have to look at the purpose of the deployment. You know, is this going to be machine to machine communication? Is 802.11 even the proper protocol that we want to use? Or do we want to look at something more proprietary to ensure the latency requirements for the data transmission will be met? You know, we want to make sure we're using the radio type that's going to be able to survive any kind of interference. Are we going to need to use frequency hopping? in order to guarantee delivery from one end to the other. So there's a lot that you have to take into consideration. You want to make sure you're specking out the correct type of antenna for the application. So this is and has been the subject of multiple other webinars all on their own. 2 of it I know of from you guys, let alone the whole white paper that 7Signal keeps updating about, correct antenna selection and application. But this holds true here too, because the last thing you want to do is put a little 3 dBi rubber duck on industrial antenna that you're then putting inside a steel box. If you're using 2.4 or 5 gig, it's really not going to go anywhere. So I really don't know how further to go into that, because if you want to know more about antenna selection, you can go check out some of their other videos. But please, and this is from the bottom of my heart, I beg you, for the love of all that is holy, when connecting these things up, please, please, please seal them. Seal your your Ethernet connections, seal up your antenna connections. It doesn't take but an extra 10 or 15 minutes. Make sure your installers are doing it correctly. You can go to Home Depot or Lowe's or wherever and get rubberized mastic tape, and you can go do it yourself if you can reach it. But I cannot tell you how many failing installations were failing because nobody took the extra few minutes to weatherize their connections. Everybody knows if you get water in an AP, it ruins the AP, but if you get water in LMR or pigtails, it ruins those too. You get water in an antenna, it's not going to function properly anymore either. They become non-reliable and you have to replace those. So when you think about that, especially if you're installing it somewhere high up that's difficult to get to, you need a lift, not only the difficulty of getting to it, but the cost of getting to it, because you're going to have to rent lifts if you don't have your own. You're going to need the qualified personnel to operate it. And you're not going to do anything on an industrial site without all of the proper safety protocols going on. So then it also becomes a very large time investment. So, making sure that you're properly weatherizing those connections is a huge, huge deal. So I'll quit harping on that. Jim, we doing good on time?
Yep, we are good. We maybe another 10 minutes or so.
All right, well, let's play a little game here. All right. So what I'm going to do, Jim, is I'm going to put you on the spot. I'm going to pull up a picture. I'm going to give you just a smidge of background information. And you and or anyone in the chat want to toss out what they think the main problem is.
Nice.
Let's see what we can do here. And these are all real situations. These all come from my site visits.
All right. Well, chat, play along. I won't shout it out right away, but
right. But the names have been changed to protect the innocent.
Gotcha.
All right. This is an industrial site that creates long tubes of rubber roofing to be rolled out for commercial buildings. Behind me when I took this picture was one of the machines that actually spits out these rolls. This was one of the storage racks right next to it. And they were complaining of poor Wi-Fi reception on the floor.
Unsurprising.
So anybody who's done any sort of warehouse Wi-Fi should be able to kind of pick this up pretty quick. I can't see the chat, so I don't know what's going on.
I got it. Gary, I think Gary and Joe were on it. Gary says omnidirectional AP mounted way too high. And then okay. Joe inserts directly on top of rack.
Yes.
Face palm.
Absolutely. He's right on target. This sucker was way too high. Now, in some circumstances, internal omnis are fine. It depends on the situation, obviously. But in this case, yes, way too high. And then you're absolutely right. It was directly over the rack. So I don't know who they were trying to give coverage to. Maybe the occasional bird that flew in, the rats of Nim. I don't know. Anybody but whoever's on the floor. How about that?
Maybe they thought the workers would be scanning inventory from the top rack. Just,
yeah, I see just a hop from rack to rack. Yeah. Okay. I wouldn't want that job.
No.
This was a beautiful day at a mill down in Florida. And they had a 2.45 gigahertz backhaul system for some monitoring equipment. And this is approximately 14 stories up.
Wow.
Do we have any ideas of what the issues could be here without any further background information?
I've got some ideas. I want to let the chat. Joe is not pleased to see those omnidirectional antennas again. I'm not sure that's a
Yes,
problem. Maybe. Guess it depends on what where the monitoring stuff is, but
it would be down on the ground.
oh, yeah, that's going to be an issue. While we're talking about the antennas, just from that image, it looks like one of them doesn't match the other three. Could just be the image
I think
itself.
that's just the picture and how they're oriented.
Some jokes about cloud Wi-Fi being 14 stories up, and
right. So yeah, the big thing here is the antennas. These were 3 dBi and 5 dBi respectively for 2.45 gig. And how they expected that to reach 14 stories down off rubber duck antennas, I have no earthly idea. And I just spent 3 solid minutes harping on it. They weren't sealed, they were just screwed directly on.
Pedro says that's not an outdoor AP as well. So
you know what? I don't think it was. It may have been plastic housing, and so they may have thought it was, but I don't think it was fully. It was not like it was IP66 rated.
Yeah.
And what's great too is the cable kind of dangling off of it. That was the Ethernet. I'm glad that was really secured to it.
No drip loop.
No, well, I mean, you figure your Ethernet is, you got a loop behind it, but then it's just going down, down, connecting somewhere back over here, just kind of flopping in the breeze. It's good stuff, man. You can't make this up. They had a bird problem, but other than that,
nice.
So this is a screenshot of a Cisco controller of a profile.
Goodness.
This profile was used in multiple places at the same site for multiple different environments. This one should be a pretty easy one to spot for all you Cisco controller people and anybody who really knows how to read. If you can't read, I can't help you on this one.
Oh yeah, chat's all over it. 30 dBm to 29 dBm. Luckily, most of their APs actually don't transmit at those power levels, so it's not going to be quite that bad. But yeah,
right,
way too loud.
They're what, normally like 23, 24, but then you've got generally a 3 to 5 dBi antenna on top of that, so you're getting pretty close.
Yeah, everybody's in the chat is saying it's all about that.
Oh yeah,
TPC
that
min and max.
Level. Hey, can't connect. Let me turn it up, right? Let's add more APs. Let's put them all at the highest power we can possibly do, right? What's really great is this was one of those locations that was applied to. Now you may have to look close at the picture.
Yeah.
But there's several different things going on here.
So this was a accepted and completed install?
Well, yeah, this had been up and running for years.
Oh my.
All right, and so let me go ahead and point out that this is not a light. This is open window with no glass. This is open to the universe.
Gotcha. So the chat is extremely active. I think the first person that saw what I saw was, again, Joe Clark, external AP with no antennas.
Okay, well, it is an external AP. It is 26 feet up, and there are 2 antennas right here. 1 and 2.
Oh, okay, yeah.
And Jim, we've had this discussion before last time I was here. These are these awesome 9 dBi Omni antennas.
Wow.
At 26 feet up in the air. And as you saw by the controller profile, cranked up at max power.
Oh my goodness.
But and again, and to top it all off, you can't tell in this picture, but when I was on site, you could see pretty clearly that, none of those connections were sealed up either.
Of course not. So, to get 9 dB of gain in the horizontal plane, we do that by sacrificing
beam width,
vertical plane.
Yep.
Coverage. So
your nice fat donut starts going down to this skinny little pancake.
It's a disc.
That frisbee of coverage, and it is also an indoor AP. So how awesome is that? I think that's the last one I got. So do we have any interesting questions?
Yeah, we do. And just catching up on the chat, we've got a lot of funny people in our chat today. That's been fun.
We should have called this dumpster fire Wi-Fi. But
we should have, yeah. Bad fi. Shame the bad fi. So first question. This goes back to, I think, the spec and slide you were showing with Channelizer. And question is, how do you deal with coexistence? Is that Phonics Contact? Is that running at 2.4 gigahertz?
Phoenix.
Contact. Gotcha.
Phoenix Contact. This one is actually this particular model is dual band, but like many industrial APs, it's not simultaneous dual band. It's software defined, so you're either running 2.4 or you're running 5 gig. And this particular one is 802.11. Okay, so this follows our Wi-Fi standards. This one is 900 megahertz. This one, and it is proprietary. It's frequency hopping, but it's modulation and everything else is Phoenix Contact secret sauce. So really, the only way to do any sort of checks is going to be through spectrum analysis.
Yeah. Put up another transmitter and see if that avoids it as it hops across.
Now, as far as coexistence with in 2.4 of Wi-Fi with things like, say, wireless HART, your saving grace there in general is wireless HART is fairly low power, and so typically there's not a lot of overlap because again, wireless HART is not using a full 1 watt, and you typically don't have multiple wireless HART devices all together in one group. They're fairly well spread out. Now, could that happen? Am I saying that's never happened? No, but in general, it's not too bad on coexistent. But the bonus with Wi-Fi is you can always move to 5 gigahertz and not have to worry about it. Whereas wireless HART can't. It's 2.4 only.
Yeah. Gotcha. Question from Andrew, and I can probably take this one. He says, in regards to airplane travel, will the 6 gigahertz band finally open up for Wi-Fi on planes?
That's kind of industrial, I guess.
The FCC actually allows airplanes to use the 6 gigahertz band in the LPI mode, but I am skeptical that we'll ever see it. I mean, there's not. One of the benefits of doing Wi-Fi at 30,000 feet is you don't have a lot of interference, so you can use the whole 5 gigahertz band and 2.4 gigahertz band, and you're done. And then you don't, the other thing with 6 gigahertz is you need, airplanes fly across borders, and you need some regulatory harmonization before you want to start thinking about 6 gigahertz. So I think it would be years, if it ever happens, before we see that on planes.
That was the easy one. Thanks.
Yeah, easy one. Forrest says regarding the ingot stacks, which a lot of people in the chat mistook for stacks of US dollars or gold bars. We were all kind of disappointed when it was just,
No, it's
ingots.
it's zinc.
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 There you have it. He says, let's say you're walking in the row between the stacks using a laptop or whatever. Will the Wi-Fi be degraded because of the nearby metal?
Yes.
Yeah, that's an easy one. It will.
That is an easy one. It most absolutely will. As we all know, some reflection is good, but the amount of reflection that you get there is off the charts. So yeah, that's part of why I was there.
So interesting question here from Ali. He says, do you take multiple antennas and an AP with you during your first visit to show/prove the issues, or just showing RSSI using a site survey tool? Is that good enough?
To be honest with you, most of my storytelling ends up going on with spectrum analysis. But there have been cases where I do go ahead and stop the overall survey specifically to show the client what I'm able to find out in a passive survey. Because honestly, with I use air magnet, and I've gotten used to it, and I've been able to pick out that you can actually, if you know what you're looking for, you can see areas of large reflection if you know where those access points are. And in this case, I knew exactly where the AP was, but I was seeing really kind of hot flare-up spots throughout the passive survey that there's no way that they could actually be that hot when the AP was, 30 meters in the opposite direction. That the only answer for that is these blobs of reflection that the passive survey was picking up. If the site plans weren't hush hush, I'd show you the survey, but that's stuff I can't show on a webinar.
Gotcha. Thanks. And maybe one last question, Heather, and this is from Fabiano, and he says, what do you do to a client who is adamant to install an Omni AP at 14 meters high? Would you sign the design or better find another client?
I've never experienced a client that was that adamant. But my response would be to show them 3D propagation patterns so they could better understand exactly what's happening. There's a lot that you can just go out there for free and find just images online that can explain and show them visually of exactly what they would be doing and why they would need a different antenna type. And I believe IBWave actually has one of those 3D propagation generator things that you could really put any antenna to. I've never used it. I've just heard about it and seen some of the pictures of it. But I would go that route because 9 out of 10 times, if they can fully visualize it and understand what's going on in the RF, it becomes easier to move them in the proper direction.
Nice. Sounds good. Well, thanks a lot, Scott and Heather. I think we're ready to transition.
Wonderful. And I think with that, Eric shall likely emerge from his hiding
from his hobbit hole.
Hello, everybody. I am so grateful to be here. That was fun stuff, Scott. Really appreciate that. Right on. So, you were talking so much about spectrum today. I'm just dripping at the thought of showing spectrum analysis inside 7 Signal. So let's do that. Hey, everybody, it's time. It's time for 7 minutes with 7 Signal, where we take a little feature inside 7 Signal, unpack it, and show you how it can have awesome, tremendous value. So let's share my screen and do the little button here and click on that one right there, and then hit the old share again. And if you can see that, give me the thumbs up. All right. Okay, guys, here we go. So as you may or may not be aware, there is a little spectrum analyzer chip inside every single Sapphire Eye. We're looking at a steel yard, so we're kind of sticking with our dirty jobs theme here today, aren't we? This is a steel yard customer of ours, and it's dirty. It is filthy. So inside, like I said, we've got a spectrum analyzer inside. We're looking at the line chart first, and this is cool. And the reason why this is so cool is because basically I'm getting a signature back from like 50, 60 spectrum analyzers at once. Wow. All right. So walking around and kind of getting the lay of the land is cool. But when I can have all of this information brought to me from the comfort of my Copley, Ohio corner office, that's pretty slick. So as you can see here, we're looking at the last 2 days. I've recorded what is going on in the air over the last 2 days. And just like Scott said earlier today, a lot of these signatures, they're not Wi-Fi signatures. So you have to have a spectrum analyzer in order to truly see what the heck is going on in the air. So what jumps out when I run this kind of generic report, hey, just show me everything. What jumps out to me is this brown line right here. Look at that. Okay, you see that, you know, kind of like that frequency hopping type of stuff that Scott was talking about earlier. And all I need to do is just kind of mouse over that and see, C50, Highland. I know where that is. Okay. And again, we do this because it gives us the cues and the clues that we need in order to know that it's safe to operate in this band, or maybe we need to avoid it altogether because it's being used by some other piece of equipment like Scott was talking about earlier. You know, if there's a $500,000 piece of equipment there, then you know what? You got dibs. We're going to go and we're going to operate on a different frequency band because that one is in use. No way to really know that unless I can see the signature. All right, so you can do that for all of these other ones as well, where you can mouse over them and you can see what's going on and where. What you're looking for on the line chart for Wi-Fi are these 3 humps, right? The rise of the, here's channel 6, the rise of the energy, okay? And then the energy at the top and then the fall, okay? So the 3 humps for 1, 6, and 11. Now let's scroll down a little bit here and take a look at our waterfall. Again, as a reminder, because we've done this a couple of times, we're waterfalling from the beginning of the day to the end of the day. And what is left behind is our favorite spectral Wi-Fi slug leaving his energy path. Okay, so here we go. There's a few cool things that I saw in here that I was hopefully wanted to get some opinions on, Scott and Jim. For example, look at this. So this is not what you would typically see. This hot to trot from top to bottom here, and the same thing over here on the right side of your spectrum. This is a little odd as well. And you know what? Look at this right here. This is a little bit odd as well. I'm not sure that this is frequency hopping because Bluetooth, I don't think is that wide of a signature. I thought that Bluetooth was like 1 megahertz wide. This looks like it's 2 or maybe 4 megahertz wide. Can I have the replay official kind of give me some insights here? Go ahead.
What do you think, Scott?
I thought Bluetooth LE moved to 2 megahertz wide channels with 1 megahertz wide spacing, so it could be.
Okay. And there you have it. Any opinions, Jim? Look,
I think that loud narrowband transmitter, well, it's clearly not frequency hopping because it's just sitting on one channel, but
that's right.
I think that's a little bit higher than the lowest BLE advertising channel. So
yeah,
there's
so
something
there. Something there.
Yeah,
definitely got some high usage going on with all that red.
Exactly.
Yeah, and it's transmitting 24/7. You know, the timing of transmission is interesting too. Yeah,
that's true, because normally we would see something more like this where it was kind of intermittent, and obviously here's your advertising channel on the right. You've got another advertising channel about right here, and then you have the other one on the far left right there. And when you see, you know, kind of this action going on right here, especially with the BLE kind of lit up advertising channel lit up the way it is, it kind of, you know, indicates, hey, Bluetooth in use, and you can kind of see it kind of moving back and forth and such like that. But again, when you see it kind of camp out like what we were seeing a moment ago, then it could be, you know, cause for alarm in terms of what the heck is that. And then in those cases, yeah, get out there, look around, you know, kind of find it, and then take steps accordingly with regards to, you know, remediation. Or again, if it's something really important and you can't remediate, then you do your best to try to avoid. One more time right here, I want to share with you this. I just find to be a very interesting signature from top to bottom. You see that, guys? And I just find that to be a little bit peculiar, not what I would typically see. You can see, Wi-Fi signature hot to trot right here on channel 6, looking good. And maybe all the access points are on channel 6 because of what's going on over here on channel 1. I don't know. But we have some photographic evidence of what's going on in the environment as a result of having our Sapphire Eye there. So there you have it, guys. That's what I wanted to share with you today. Interesting stuff, awesome topic. And I just want to remind everybody out there that we can't see, we can't hear Wi-Fi, but with 7 Signal, we can. Thanks for joining us, everybody.